the launch pad. Once the rockets are completely assembled, final launch preps begin. For Atlas V rockets, launch countdown begins with moving the rocket from the VIF to the pad. The quarter-mile trip uses 6 components to complete the 20-minute trip. Weighing in at about 2 million pounds, the MLP supports the rocket and contains air conditioning, electrical, and commodities, while the undercarriages bear the weight of the MLP and rocket. 2 rail cars lead the move, with the payload van providing communication to the payload, while the ground van houses the ground support for the rocket. At the rear of the convoy, the portable environmental control system provides air conditioning to the payload and rocket. Finally, track mobiles provide the power to move the 3.5 million pound convoy. For Delta IV Heavy rockets, the process looks quite different. Approximately 9 hours before T0, final preparations begin as 40 hydraulic cylinders at pressures nearing 3,500 psi move the 10 million pound MST. It's first raised 8 inches and then rolled back. Delta uses a carriage transporter system, traveling at about a quarter mile per hour. It takes about 25 minutes to roll the MST to its launch position, 345 feet north of the Delta IV rocket. The Delta IV rocket stands 217 feet tall, or about 21 stories, and weighs more than 900,000 pounds fully fueled. On the day of launch, nearly 30 engineers and managers are polled for system status and readiness to proceed.
Status check to proceed with terminal count, Atlas Systems, propulsion.
This is the final status check before launch for all Atlas and Delta vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants.
Range coordinator. Clear to proceed. Launch director.
Launch vehicle is ready to launch.
Mission director.
This is the mission director. You have permission to launch.
Proceeding with the count.
If the rocket is ready for flight and the weather is within the launch commit criteria, then polling will be completed and the team will have given the go for launch.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. There's ignition. And liftoff of the United Launch Alliance Atlas V rocket.
For a typical Atlas V flight, the main engine and solid rocket boosters ignite to lift the rocket off the pad. Shortly after liftoff, the rocket begins a pitchover to attain the proper flight path, minimizing the dynamic pressure the vehicle experiences during flight. Within the first few minutes of flight, the vehicle reaches Mach 1, the speed of sound, followed by jettison of the solid rocket boosters. About 4 minutes later, propellant levels deplete and the booster engine shuts down, followed by release of the booster stage. At various times in flight, depending on the mission, the vehicle jettisons its payload fairing. From there, the second stage will continue carrying the spacecraft towards its destination with planned engine starts and stops. Finally, Centaur will release the spacecraft in its target orbit to continue its journey.
LC-1, this is AC.
Go AC.
I'm ready to brief the concerns for the OCU temp.
Roger. LD Net 1. LD. MD Net 1.
MD.
Proceed AC.
Okay, the team did some very thorough reviews and ran some models. Based on that and our analysis, we have a conservative prediction from the models, and it generated sufficient margin. Plus, looking at our flight trajectory will be mainly in sunlight, so that helps the situation as is. Our recommendation is to proceed, that we have no concerns with these current temps in the OC.
LC concurs. LD.
LD concurs.
MD.
MD concurs.
This is Delta Launch Control at T-minus 4 minutes and holding. As you just heard, the Anomaly Chief provided an out brief on that anomaly with concurrence from the Launch Conductor, Launch Director, and Mission Director. So in just a short few moments, we'd expect to be hearing a new T0 from the leadership team. So we'll stand by.
LC, LD channel 1.
Go, LD.
LC, please coordinate a new T0 of 07:28:00 Zulu.
Roger, 072800 Zulu.
Good copy.
ALC, please set the clock for T0 072800.
Roger.
RC, LC,
RC.
please coordinate with the range, new T0 072800.
072800 Zulu in work.
This is Delta Launch Control at T-minus 4 minutes and holding. As you just heard, the launch team is now going to target a new T0 of 3:28 a.m. Eastern Time. The Assistant Launch Conductor will reset the countdown clocks for the new T0 while the Range Coordinator goes to the Eastern Range and verifies the Eastern Range can support that new T0.
LC, RC, 1.
Go.
Range is approved, new T0 072800.
Roger.
LC, ALC.
Go.
Countdown clock has been set for a new T0 of 0728. We're currently at L-minus 24 minutes.
Roger. All right, team, the clocks are set, and we have an approved T0 0728 Zulu.
This is Delta Launch Control at T-minus 4 minutes and holding. As you just heard, the new T0 has been approved, the clocks are reset, and the clocks are now counting down towards a new T0 of 3:28 a.m. Eastern Time.
L-minus 23 minutes.
This is Delta Launch Control at T-minus 4 minutes and holding. As you can see on your screen, this is a view from the Launch Control Center at the Delta Operations Center. The team in the LCC is responsible for the final pre-launch checkouts, fueling, and launch of the Delta IV Heavy vehicle. This is the Mission Director Center, or MDC. Within the MDC, you'll find the ULA Launch Director and the NRO Mission Director, who you just heard as they received an out brief on the anomaly we have been working and then provided direction on that new T0. Here's a view from our DOSC, the Denver Operations Support Center. These are engineers that are responsible for the design and operation of the various subsystems on the vehicle. These engineers would have been engaged in the anomaly discussions and in the analysis that you heard referenced as the anomaly chief provided the out brief on that anomaly we worked a few minutes ago.
Minus 21 minutes.
This is Delta Launch Control at T-minus 4 minutes and holding. As you heard a few moments ago, the range coordinator went to the Eastern Range to request approval for a new T0. ULA collaborates with the Eastern Range to prevent launching at a time that would result in the vehicle colliding with the ISS, another satellite, or catalog space debris. Our trajectories in the launch window are provided to the Space Force for analysis prior to launch day, and we're given a report several hours before launch that indicates if launch on a given minute within the window will have the rocket or payload flying near an object with a high probability of contact. This report is called a COLA report, which is short for Collision on Launch Avoidance Report. The mission director reviews the report and lets us know if there's a particular minute that we should not target for a T0. In this case, the targeted T0 was clear. Our T0 was approved, and we are counting down toward a launch at 3:28 a.m. Eastern Time.
Go.
ULA provides the analysis used by the Eastern Range to produce stay-out zones for airline pilots and boat captains on day of launch. These stay-out zones prevent intentionally jettisoned rocket pieces from landing on airplanes and boats. The Eastern Range will produce NOTAMs, or notices to airmen, to indicate to pilots that the airspace around Cape Canaveral Air Force Station and along the launch vehicle's flight path should be avoided. In the event an aircraft enters this controlled airspace on launch day, local air traffic control will contact the aircraft and direct them out of the area. The range also produces notices to mariners to provide the same information to boaters. The U.S. Coast Guard will post these notices at local ports and boat ramps. United States Air Force, NASA, or U.S. Customs and Border Patrol aircraft or U.S. Coast Guard boats may intervene if boaters enter the controlled sea space and do not respond to attempts to communicate. This is Delta Launch Control, T-minus 4 minutes and holding.
L minus 14 minutes.
ASGAS LC.
Go LC.
Establish scan pattern 140.
Roger.
VSE LC Net 1.
VSD on 1.
Verify base bending moment instrumentation is active and data is valid.
Verified active. Grafman Placard 6 Alpha for launch.
Roger 6 Alpha. OS LC.
OS.
Set BBM active.
Roger.
All personnel check your mics on Net 1.
L minus 12.
MEQ, initiate retract data logger just prior to the L7 poll.
Roger.
We have an open mic on Net 1.
L minus 11 minutes.
SYS, configure FluMon for PU shadow mode.
Roger.
Flight control, configure option 910 for PU shadow mode.
Roger.
L-10 minutes. All communications switch to channel 1. All personnel and visitors remain in present position until launch. Maintain operational silence in the LCC.
RC, verify solar radiation limits acceptable for launch.
Verified.
Terminal count briefing. If a condition exceeds a launch constraint any time after the terminal count status check, the observer shall announce hold on channel 1, identify their station, and briefly state the reason for the hold. Flight control, perform launch on time verification.
Roger.
OSM, verify the hold fire switch is in the proceed position.
Ready to proceed.
RLM, verify the red line monitor and vent table are in the correct configuration for terminal count.
Verified.
L-9 minutes.
This is LC performing hold authority comm check. LSIC RF.
Loud and clear.
Loud and clear as well. ATD.
Loud and clear.
Loud and clear as well.
LC, launch on time verified.
Roger. LC, switch to the ready position. All steps are complete prior to the status check.
L-8 minutes.
This is Delta Mission Control at T-minus 4 minutes and holding. We remain in the built-in hold as preparation for launch continues. In a few moments, Launch Conductor Scott Barney will poll the launch team for the final go to pick up the count. 27 engineers and managers are polled for system status and readiness to proceed. This is the final status check before launch for all Delta vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Scott Barney performs the final polling of the launch team.
L-7 minutes.
Status check to proceed with terminal count. First stage systems, propulsion.
Go.
Hydraulics.
Go.
Locks.
Go.
LH2.
Go.
Second stage systems, locks.
Go.
LH2.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
COM.
Go.
GCQ.
Go.
Operation support.
Go.
Pneumatics.
Go.
Umbilicals.
Go.
HASGAS.
Go.
ECS.
Go.
Red line monitor.
Go.
Quality.
Go.
Ops safety manager.
Go.
ELA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
Launch vehicles ready to launch.
Mission director.
You have permission to launch.
Proceeding with the count.
L-6 minutes.
MEQ, establish swing arm lock pins, pull.
Active.
Polling is complete and the launch team has given the go for launch. The countdown will resume approximately 2 minutes from now, but before it does, let's walk through the final checks we'll hear from the launch team. Delta IV's liquid oxygen and hydrogen tanks have been full for approximately a half hour and in topping mode to replenish commodities that evaporate while we perform final valve and vent system checks. Once the terminal count begins, you'll hear indications that propellant topping has halted on all Delta first and second stage tanks. The oxygen systems are secured first, followed by the hydrogen systems, and all tanks will be pressurized for flight. The vehicle will transfer from ground electrical power to its onboard batteries. Hydraulic systems are pressurized and the vehicle's ordnance systems are armed. At T-minus 60 seconds, the eastern range will provide the range green call indicating that weather conditions are acceptable. All supporting assets are ready for liftoff and the air and sea adjacent to Complex 37 and along the flight path are clear. At T-minus 30 seconds, Launch Conductor Scott Barney will conduct one final short status check to verify all systems remain go for launch.
Terminal count.
At T-minus 15 seconds, the ROFIs, or radial outward firing igniters, will light to burn off residual hydrogen around the base of the vehicle. At T-minus 7 seconds, the starboard engine will ignite, followed by the port and core engines at T-minus 5 seconds, and liftoff will occur at T0. After liftoff, you'll hear the voice of Patrick Moore with launch vehicle ascent data. This is Delta Mission Control at T-minus 4 minutes and holding. We anticipate releasing the hold in just a few moments.
T-minus 4 minutes.
The countdown clock is resumed. We've entered the terminal count.
3:55.
Go for launch.
Ground pyros enabled.
Minus 325.
Second stage lock, secure at flight level.
Second stage liquid oxygen systems are now secured and ready for flight.
Minus 307. Minus 249.
FTS internal.
CBC locked at flight pressure and flight level.
Vehicle now on internal power. First stage lock systems are secured for flight.
Minus 2 minutes.
Hydraulic pressure at 4,000.
Vehicle internal.
155.
Launch sequencer start.
CBC LH2 at flight pressure and flight level.
Minus 140.
FTS launch enable.
137.
The launch vehicle, payload, ground systems, and eastern range are go for launch.
Minus 120.
OCUs armed. FCS count started.
T-minus 1 minute.
Engine start, box go.
Rock, report range status.
Range green.
Minus 50.
Second stage LH2 secure at flight level.
Minus 30.
Status check.
Go Delta.
Go NROL 44.
Trophy ignition.
10.
9, 8, 7, 6, 5, 4, 3, 2, and liftoff. And stand by. We've obviously had a hot fire report.
And LC verifies MECO confirm.
This is Delta Launch Control. The last call from the launch conductor indicating that he has confirmed that the engines did not start. At this point, the launch team will be securing the launch vehicle, ensuring that all systems are saved.
3 seconds. Received a TISR abort.
Roger. And are you ready to reset the clock T-4 and holding?
Roger, ready.
Roger. ALC reset countdown clock to T-4 minutes and holding.
Roger.
LC, SCS in pre-flight mode.
Roger. Prop 1, verify safe RS-68 shutdown and following purge configuration.
Active, sir.
DST-1, LC. DST-1, best source select number 4 to switch best source select number 1 and best source select number 2 force to channel 1.
Roger.
MEQ, swing arm lock pins install.
In work.
And LC pad looks nominal. OSM, can you verify?
We're doing sweeps right now.
Roger.
I don't see any fires.
LC, lock pins installed.
Roger. ALC, establish engine cooling water off.
Water off.
LCOSM.
OSM.
Sweep complete, no fires.
Roger. And USO, you can verify same.
USO verified.
Roger. And MEQ, Elsie.
Go ahead.
Did you verify lock pins installed?
Yes.
Roger. All right. Report system status, Field 1.
Field 1 nominal.
Field 2.
Field 2 nominal.
Locks 1.
Locks 1 nominal.
Locks 2.
Locks 2 is nominal.
And Prop 1.
We're still looking, sir, but we think we're nominal at this time.
Roger. Report 1 complete.
Roger.
And PNE, have you established PSN2?
Verified.
HYE, secure hydraulics.
Roger.
Has gas, establish scan pattern 305.
Roger.
GE, establish arm igniters, reset.
Reset.
PNE, verify nose cone purge on and set heater to 164 degrees.
Verified.
OSM, Elsie.
OSM.
Report ready to safe vehicle ordnance.
Ready.
And verify OSM concurrent safe FTS.
OSM concurs.
FTS, command FTS safe and external.
In work.
This is Delta Launch Control. As you're hearing on the net, the team is working to secure and safe the vehicle. Swing arm lock pins have been installed to ensure the swing arms will not be retracted, and all vehicle systems are being evaluated for their status. So far, all nominal calls from all of the operators relative to their systems on the ground and on the launch vehicle.
MEQ, report swing arm system secured.
Secured.
ALC on TC emergency panel, remote cameras normal.
Normal.
PNE, configure helium supplies.
In work. LC, flight control is ready to detaking.
Roger. LD, LC, that one.
LD on 1.
LD, we had a hot fire abort at T-minus 3 seconds. We have performed our abort sequence securing. We are ready to proceed into detanking operations.
Proceed, LC.
All right, team, we're proceeding to Operation 80. And RC notify range of decision.
RC copies.
Flight control terminate option 910 and reset 910 flags.
Roger.
And LC to 1 when able.
LC go.
Yes, sir. Prop 1. Filing can state systems nominal.
Roger.
Option 910 terminated and flags reset.
Roger. And flight control re-enable MSE Adams limit monitor.
Roger, it's been worked. MSC limit monitors are enabled.
Roger. RLM LC.
RLM, go ahead.
Stop red line monitor.
Roger.
LC flight control is ready for clock to reset T plus 5 minutes and counting.
Roger. ALC adjust clock to T plus 5 minutes and start plus count.
Roger.
Has gas LC.
LC, RLM.
Go ahead.
Go RLM.
RLM is stopped.
Roger. Has gas. Proceed to scan pattern 305.
Roger.
And MEQ, we've already established swing arm lock pins installed.
Roger.
Shut down swing arm hydraulic system.
Roger.
OSM LC.
OSM.
For step 70, drop FHA roadblocks and establish BDA roadblocks.
Roger.
OSM SRM ignition disable.
Just disabled.
SYS LC.
Go.
Establish T for PCM data transfer to nominal per data station PCM selection item.
Roger.
PNE LC.
Go for PNE.
Perform initial securing for step 70.
Roger.
MEA LC net 1.
MEA, go ahead.
Yeah, can you verify FEVBS covers remain intact?
Yes, sir. They all are intact.
All 9. I just want to repeat, all 9 are intact?
All 9 are intact.
Roger, thank you. FTS LC.
Go ahead.
Step 90, secure RF, FTS, and GPS MT.
Roger.
ABE, disable EIB heaters.
Roger.
LC, LD on channel 1.
Go LD.
LC, the MD has declared a scrub for today's operation. Please proceed with detanking operations.
Roger.
This is Delta Mission Control. It's now been confirmed that Delta IV Heavy NROL 44 launch activities will not continue this morning, and a new date has yet to be identified. For the most up-to-date information, please visit ulalaunch.com, follow us at ULA Launch, or call 1-877-ULA-4321. This concludes this morning's coverage. I'm Dylan Rice. Thank you for joining us.